troubleshooting and repair procedures. Now, before moving forward in this section, there are some safety concerns that I need to cover to make sure that you understand what you are doing and you are not endangering yourself or others. First, you need to contact professionals and qualified servicemen for equipment that poses risk. What do I mean by this? This is a simple and straightforward sentence. That means if there is an equipment or a device or a board that is in a risk environment, a chemical or high electricity, high voltage, high power environment that you are not trained to deal with, you should call someone who is trained and who can be in that environment and interact with things. You might end up killing yourself if you try to fix something in an uncontrolled environment that has chemical reactions and things that might hurt your life. The next thing that you need to make sure of is that you have proper tools before moving forward. Not having proper tools might end up killing you. We already mentioned that you need a screwdriver with an insulated shaft when you are dealing with high current or high voltage screws, because you might end up touching the shaft and killing yourself if it wasn't isolated. And using that very same concept, you can apply this to all of other equipments. Any equipment that you use must be the right equipment that is used for the right job. Don't use or try to use anything that you have in hand, because this will hurt you and will hurt the equipment that you are trying to deal with. The next step is instruments must be well maintained and correctly calibrated. Some instruments needs professional calibration by an expert in the field. So if you are dealing with a chemical equipment board, you must make sure that someone from the same field is there with you to help you know what are the right adjustment, what are the right values for the calibration in order for this board to work correctly. When dealing with voltage, you need to make sure that you are disconnecting or isolating power before moving forward in testing and trying to figure out what's happening. Also, make sure that you are using insulated gloves and tools, as we already mentioned. Make sure that you are using GFCIS, which is Ground Fault Circuit Interpreter. This device will make sure that if there were electricity, you won't get killed in the process. It will do its best to make sure that you stay alive if something happened while you are dealing with that circuit. So it's like a ground circuit breaker, but you are holding it in your hand and it's saving your life while you are working on the device that you are doing the maintenance for. Make sure to have it and make sure to use it correctly to make sure that it will help you finish the job without getting killed. Again, here we are dealing with devices that has power, and when you are doing this, you must make sure that you stay alive. Your life matters more than that device, so don't get foolish and just get to it and start unscrewing screws and just getting the job done, because you might end up killing yourself. Main concerns: the effective and efficient working condition of a certain laboratory equipment depends on the following 4 features: maintenance, servicing, troubleshooting, and repair. Now, the first thing that we are going to cover is the maintenance. Maintenance is a continuous process. It must include both the hardware and the software maintenance. The hardware maintenance includes cleaning, dusting, and making everything crisp clean, maintaining prescribed level of parameters such as electrical, environmental, and other parameters depending on the type of board, device, or system. The software maintenance includes reinstallation or uninstallation of the software, upgrading the software if there is any new version comes up. So again, maintenance is a continuous process and it's a must in every device or board that you are using or that you are dealing with. Sometimes the problem with the device is a bad software. Sometimes it's dust all over the board, causing short or causing the board to function abnormally. So you need to make sure that you avoid all of these first before going to the troubleshooting. Now, the second step in main concerns is servicing. Servicing is mainly associated with the hardware parts of the equipment. It includes checkups, repairs, and updating of all physical components. Servicing has a lot of steps that we can summarize as follow. The first step is uninstall. Uninstall all physical components starting from power connections. Then move to dust. Dust cleaning is a very important part, so you need to clean the dust from the components. After that, you need to move to performing a visual check or electronic check as required. Then reinstall all components carefully and properly. After that, you need to check for loose wiring or cracked cables. Again, you need to check if any jumper is missing. If required, replace it with a new one. If there is a physical damage of peripherals and you need to replace it if needed. If there isn't, you need to leave the peripherals as it is. After that, you need to make sure that you are tighten all internal and external connections. Then you can switch on the power supply and observe if the device is functioning correctly before moving to the troubleshooting phase. Hello and welcome. Now we are talking about the third step in main concerns, which is troubleshooting. Troubleshooting means detection and rectification of faults in the equipment. After troubleshooting, you can move on to repairing, which means repairing or rectifying the problem in the hardware or software. It is an essential part of troubleshooting. Repairing may also include replacement of a component. Now, there is 6-step procedure for troubleshooting a problem, which is a standardized approach towards electronic troubleshooting and maintenance. These 6 steps will be discussed in order to achieve proper solution for your problem. The first step is symptom recognition. Symptom recognition includes determining if the equipment is functioning as designed. Each equipment or each board has a specific way or a specific input and a specific output. You need to check and know if there is a problem with these outputs, if they are out of range, if there isn't output at all. A trouble symptom is an indicator of malfunction. Use your sense of sight and hearing. Do you hear anything that's not usual? Do you see anything that's broken, burned out, or blown? If you do, you need to take proper measurement. This is the first step in troubleshooting. Next, you need to do symptom elaboration. You need to ask yourself what fault is probably causing the specific symptoms. Symptom elaboration requires an evaluation of all observed displays. You need to make sure that indications must be evaluated in relation to each other as well as the overall operation. Record information observed. Use a paper. For example, how did each control if affect an associated meter or other indicators? Think about the information before jumping to a conclusion. Write down everything, try different output and observe the try out different input and observe the output. Do you see anything that's not usual? Do you see any change or spike? Do you see something that's broken? Observe, write down, don't do anything. At this point, you are only just studying the whole problem and trying to figure out what's happening. Now, you need to list probable faulty functions. You need to divide the equipment into functional areas in order to save troubleshooting steps. Use functional block diagrams, or in short FBD, to show the functional areas of an equipment, as well the detailed functions, levels of inputs and outputs parameter for voltage and current. Making that diagram will save you a lot of time. Make sure to state the input and the expected output for each block. Then start measuring. Next, you need to localize the faulty function. Now that you have a block diagram with all the required functions, you need to start isolating the functional area that has an indication of malfunction. Knowledge, skill, and proper test equipment should now be used to isolate the fault functional area. After doing this, now you have a clear idea what are the areas that have fault or problem and what are the areas that are functioning properly. Localizing the trouble of the circuit. First, you need to isolate the circuit within the fault unit. More extensive troubleshooting is now required within the identified fault unit. Look for improper voltages, improper waveforms using oscilloscope, obvious component overheating, or components that are blowing out. So use your eye, use your nose to smell, and use your hearing. Use your ability to identify problems from their physical appearance. If nothing is shown, you need to start using your multimeter, oscilloscope to start testing each component as we explained previously. Isolate the defective circuit group. After this, you need to do failure analysis. Step 1 and 2 were used to recognize, verify, and obtain descriptive information. Step 3 in our process allowed you to make a logical selection of the logical fault unit. Step 4 provided for simple input-output test and localized the faulty functions.